Hi, this is Dr. Eddie Morgan over at Clovis East High School, ready to help you with your homework tonight. Tonight we're going to be looking at homework help for Math 1 Worksheet 3.3a. Remember, every problem on the homework help mirrors the problem on your homework. So if you're having a problem with one problem in particular, fast forward to that problem and see our explanation here, and it should be able to help you. Let's get started. Problem 1 asks, what is the equation of the line with the slope of 5 and the y-intercept of 3. You remember our slope-intercept form of an equation is this: y equals mx plus b. M, think mountain, that's our slope. B is the beginning point, or the y-intercept. What is the value of y when x is 0? Now in our case, here is our slope is m, and our y-intercept is b, so we just have to plug in these numbers into our equation, and we have y equals 5x plus our b is minus 3, and we can rewrite the plus minus 3 as y equals 5x minus 3, and that's the equation of a line with a slope of 5 and a y-intercept of minus 3. Problem 2 asks us to write the equation in the slope-intercept form. That is the y equals mx plus b form that represents the line that passes through these 2 points. Well, the first thing we want to do is find our slope. So you remember our slope is to find the difference in y, so I take the 2 y's and subtract them. The y in the second point minus the y in the first point, that's what that subscript means. And the x in the second point minus the x in the first point. All right? So what we're looking at here, if I were to do it this way, I would do this little line here. I'm going to take the y in the second point and subtract the y over there. So I'm going to have negative 1 subtract 5. And then my x's, x here and x here, I'm going to have 2 minus 1. Now be very, very careful of your negatives when you're doing the slope. That's the most common error in this unit, is subtracting, and particularly subtracting negatives. So now let's do this. We have minus 1 minus 5. So that's going to be minus 6. And here notice that when I subtract the negative, this just becomes 2 minus a minus 1 just becomes 2 plus 1. So I can say this is minus 6 over 3, and if I simplify, that's simply minus 2. All right, so we have our slope of our line. Now we just have to find the y-intercept. Now lots of times when we work problems with tables, we would see a value where x was 0. We don't have that here. So what we're going to do is, we do know, so far in our equation, we do know that y is going to equal minus 2x plus b. We know that much, and we're trying to find b. So what we're going to do is we're going to pick one of these points, and it doesn't matter which point. I'm going to pick the second point. I'm going to pick this point right here, and I'm going to put it into this equation, okay? So the y is minus 1. Make sure you put the y where it belongs, not in the x, equals minus 2 times the 2, and then plus b. Now you see I have one variable, so by solving this, I'll find out what b is going to be. So minus 1, negative 2 times 2 is negative 4 plus b, and now we'll solve. We'll undo the subtract 4 by adding 4 from both sides. 4 minus 1 is 3. And that goes to 0 equals b. So there's my b now. So now I have a slope of minus 2 here, and I have a b of 3, so I can now write my equation. Y equals negative 2x plus 3. Okay. Now if we wanted to check it out, we could put the other point in here and just see if it worked. So if I put 5 equals minus 2 times minus 1, plus 3, we can see 5 equals minus 2 times minus 1 is plus 2 plus 3. And notice that 5 indeed equals 5. So we're good there. Okay? Just a way to check out that we got the right number. The third problem asks us to draw a graph of this equation, y equals 4x. Well, you remember y equals the slope plus that. So notice my m, my slope is 4, and my y-intercept is 1. Okay? So what we're going to do here, our y-intercept is 1. Because b is 1, that implies that we have the point. The y-intercept is the point 0, 1. You can kind of see that looking into our equation here. If x was 0, then 0 times 4 would be 0, so y would be 1. So let's set it up here. First we're going to need to draw an axis here, so I'm just going to draw it right here in the middle. This is my y, and this is my x through here. And then our first point is 0, 1. Now to draw the next point, we use our slope. And remember, our slope is 4, or we could write that as 4 over 1, which is the change in y over the change in x. So what I do is I start here, and I'm going to go up 4. From here I go 1, 2, 3, 4, and then I go over 1. And so my second point is going to be right here. Notice my little triangle here I created. Plus 4, plus 1, 4 over 1. And so my slope, and by the way, I could go backwards too. Down 4 and over 1 is another point. And my line is going to go right through those points there. And there's the graph of my line. Problem 4 is a vocabulary question. It asks, is y equals 7 a linear equation, and explain why? Well, there's a couple ways to look at this. One way to look at it is our typical linear equation looks like this. Y equals mx plus b. Does that look like that? Well, at first you say it doesn't, but I could write it this way. What if the slope is 0? 0 times x plus 7. Notice 0x would be simply y equals 7. In other words, it is a linear function. It has a slope of 0 and a y-intercept of 7. So if you looked on a graph, the y-intercept would be up here at 7. 1, 2, 3, 4, 5, 6, 7. That would be the y-intercept, but then it would have a slope of 0, no rise, so it would simply be a horizontal line. So y, and notice everywhere, no matter where I pick here, y is always 7, 7, 7, 7, 7. Okay? So y equals 7 is a linear equation for a horizontal line. Question 5 says, is it always, sometimes, or never true that an equation in slope-intercept form represents a direct variation? All right. Now, in a direct variation, there's a couple things that are true. The most important thing to know is that because it's a direct variation, it ends up having the form, usually this kind of form. Y equals some number times x, a direct variation. And if you look at our equation for a line, y equals mx plus b, you can see that in a direct variation, k ends up being your slope. But the one thing that's missing here is there's no y-intercept. Or, in other words, this is the direct variation. This is y equals kx plus 0. So, in other words, if your y-intercept is 0, if b, your y-intercept is 0, then your linear equation, your linear function here, is a direct variation. Okay? So, for example, y equals 3x is a direct variation. However, if b is not 0, then the line is not a direct variation. So I can take a line with the same slope, for example, y equals 3x, and just put plus 1. And now because I have a y-intercept that's not 0, it doesn't go through the origin, then it's not. In other words, in a direct variation, it always goes through the origin, whatever it is. However, in other ones that don't go through the origin, then that's not a direct variation. So the answer to our question, Always? No, never, but sometimes. Sometimes is my answer, because if the y-intercept is 0, then it is a direct variation. If it's not, then it's not. So our answer is sometimes a line can be a direct variation. Problem 6 asks us to describe two different methods to graph this equation. Well, one method we've seen already is if I look at y equals 3x plus 6, then I know that my slope is 3 and my y-intercept is 6. So if I'm drawing a graph here, I can come up to 1, 2, 3, 4, 5, 6 and put my point right there. And then my slope is 3, so I could go up 1, 2, 3 and over 1. And so I could go up 3 over 1, put my next point here, and then I could draw my line. So using the slope of 3 over 1 and using B as my point, my y-intercept here, which is 0, 6, I can go up 3 over 1 and get another point, and I can go there. Now, a second way we could do this problem is if I have y equals 3x plus 6, I could plug in some values for x and see what y got. For example, if I let x equal 0, so I have y equals 3 times 0 plus 6, notice I get y equals 6, and so one of my points would be the point when x is 0, y is 6. That's our y-intercept point we expect. Well, let's let x be something like 1, okay? So if I let y equal 3 times 1 plus 6, notice I get y equals 3 plus 6, or y equals 9. So another point would be 1, 9. And you notice on our graph here, just like we did before, if I do 1, 2, 3, 4, 5, 6, 7, here's my point 0, 1, 2, 3, 4, 5, 6. Here's my point 0, 6. And then my next point is 1, 9. So here I'm at 6. So 7, 8, 9, and then over 1. And there I get the same graph as before. So the two methods are, one, use the y-intercept to find a point, starting point, then use the slope to go up and over to find the next point. Or just start plugging in values like 0, 1, 2, or minus 1, minus 2, and find two different points that way. And that's a second way you could graph this. Problem 7 asks us to find the slope and the y-intercept of the graph. What we're going to want to do here is we're simply going to want to put this into the form y equals mx plus b, because that's our slope and that's our y-intercept. Now we start with the function here, y equals 3, and so you notice we got to get rid of this minus 3 on the other side. We got to solve for y. So our first step is to undo the minus 3 by adding 3 to both sides. And now we get y equals minus 2x plus 3. So our slope is right here. So slope is minus 2. And our y-intercept is right there. B is going to be 3. And that's our answer. Similarly for number 8, to find the slope and the y-intercept, we just need to solve for y. Get y by itself and have the x term first and then the second. There's our slope. There's our y-intercept. So we start with y minus 8x equals 1/3. So we need to move the 8x to the other side. The opposite of subtracting 8x is adding 8x. And then that's y. That cancels out. And we have the 8x first plus 1/3. So our slope is going to be 8. And our y-intercept is going to be 1/3. Again, number 9, we need to solve for y. We can solve for y and put the x term first. Then that's our slope. And that's our y-intercept. Okay? So let's start over here with our problem. Minus 2y equals 4 times 3 minus 5x. Well, first of all, we need to undo this right side here. So we're going to distribute, and we get minus 2y equals 12 minus 5x. Notice that we also want the x in first. If you notice here, the x is the first term. So I can turn this around and make it minus 5x plus 12. Now to solve for y, we just need to undo the multiply by negative 2 by dividing by negative 2, and we divide everything by minus 2. Okay, so that becomes 1, and now I'm left with y equals a negative divided by negative is positive, so I have 5/2 x, and positive by negative is a negative, minus 6. So there's my slope, and there's my y-intercept. So if I want to write it out here as the answer, the slope is 5 over 2, up 5 over 2, and my y-intercept is minus 6, which is the point, by the way. Remember, 0 minus 6 is the point. When we say y-intercept, we mean what's the value of y when x is 0. 10 is interesting because we're trying to find it in this form here. If I write it y equals mx plus b, you can almost see it by looking at it. Look at this. This is plus a. So one thing I can say is, oh, b equals a in this case. And m, what's being multiplied? M, you see, is 3 minus a. It's the number being multiplied by x. So this is just kind of, you don't have to do anything but kind of look at it. What's the number being multiplied by x? That's the slope. What's being added? That's the y-intercept. Problem 11 is a polar bear problem. It says that polar bears are listed as a threatened species, and in the year 2005, there were 25,000 polar bears in the world. That's the beginning point for our problem. And now if the number of polar bears declines by 2,000 each year, when will they become extinct? Well, first off, where's the beginning point here? My b, my y-intercept, is going to be 25,000. Okay? Now when I go to measure here, I'm going to let b, big B, equal the number of polar bears, not to be confused with little b, my y-intercept. And I'm going to let n equal whatever the year is. Okay? So we're starting at 2005. So what we want to realize is that when n is 2005, how does that become 0? And here's how I'm going to do that. My equation is going to be the number of polar bears starts off with 25,000, and then we decline. So decline means minus. I'm subtracting $2,000 every year. Okay? Now if I want to know what year it is, for example 2005, I want this to be 0. So what I end up doing is I take my year and I subtract 2005. So notice that when n is 2005, that's 0 and we have 25,000. Next year, 2006, 2006 minus 2005 will be 1, and we'll subtract 1 2,000. In 2007, this would be 2, we'll subtract 2 2,000. So there's our equation. Okay, so that's the equation we need. And the second part is, when will they be extinct? Well, they'll be extinct when b equals 0. So let's plug in b equals 0. So I'm going to put 0 here, and that's going to equal 25,000 minus 2,000 n minus 2005. Okay. So let's do a little distributive here first. And we get 0 equals 25,000 minus 2,000 n, and then minus times minus is plus, and let's do 2,000 times 2005, and that's going to be 4,010,000. Okay? So now we're solving for n here, so let's get the n on the other side. So I'm going to add 2,000 n to that side and 2,000 n to this side. So I end up with 2,000 n. This will go away, and let's go ahead and add these while we're at it. So 25,000 plus 4,010,000 ends up being 4,035,000. Okay? So now we'll undo multiply by 2,000 by dividing by 2,000. Divide this by 2,000 as well. And we end up that n equals 2017.5. Okay? So what year are they going to go? You could say in year 2015 and a half. So I would say the year they go extinct is in 2017. There's still some, but halfway through the next year. So the year they would be extinct is 2018. And that's our answer there. How could graphing help you solve this? Well, if you graphed it, you would start with 25,000, and you could start doing it and graphing, and you could just look, and then you'd be looking for what's the point where it goes to 0 here. And that's how graphing could help you solve that. 12 says to use the slope and y-intercept to graph each equation. First thing we want to do is put it in the slope-intercept form. That means we put the x term first. So in this case, I need to take this with the minus sign and switch it over here. So I end up with y equals minus 2x plus 6. Now you see there's my slope, there's my y-intercept. My slope is minus 2 and my y-intercept is 6, which is the point 0, 6. All right? So let's do this here. Let's draw a graph quickly. So there's my x-axis. And there's my y-axis. My intercept is 0, 6. So 0, 1, 2, 3, 4, 5, 6. Let's erase that. I'm going to erase my line. I noticed that it went off the page there. So very simply what I'm going to do is regraph that. I'm going to put my graph down lower. I should have thought about that ahead of time, but I did not. And so I'm going to put it right here. And here's x and y. And now when I go 0, 6, I go 0, start here, 1, 2, 3, 4, 5, 6. There's my y-intercept, 0, 6. My slope is minus 2. So that means from this point, I'm going to go down 2 and over 1. Okay? Down 2 over 1, and that can be my second point. And so now I can draw a line. By the way, if you don't have a ruler, one easy way to do this is just to keep doing this. Go down 2 over 1, down 2 over 1, down 2 over 1, and even backwards here. And that helps you kind of line up your lines so you can get a much nicer straight line here. And that's our graph. For number 13 again, we need to get it in this form, y equals mx plus b. So as I look here, the first thing, I've got the 3x there, so let's get rid of the 8 here. I want to get the y by itself. Think of it as solving for y. So let's subtract 8 from both sides. And so now we have 4y equals minus 3x minus 8. Now we undo the 4y by dividing by 4, and we divide everything by 4. So that gives me y, and over here I have minus 3/4 times x minus 2. So there's my slope, there's my y-intercept. So my slope is minus 3/4, and my y-intercept is minus 2. So this time I'm going to make my graph a little higher to make sure, because I'm going down. So I'm just going to go right here and put x, and put here y. And our y-intercept is minus 2. That's the point 0, minus 2. So 0, come down 2, and our first point is there. Now our slope is negative 3/4. That means I go down 3 and over 4. 1, 2, 3, 4. And there's my other point. Notice it's down 3 over 4. And now I can draw my graph through that point there. Take your ruler and finish the graph. And for our last equation, again, we want to solve for y and make x our first term. Okay? So in this case, here's y. So first thing I'm going to do is get rid of this 5x. So subtract 5x from both sides. So 5x minus 5x is 0. I'm left with 2y equals 2x minus 5x is negative 3x minus 1. Now we undo 2 times y by dividing by 2, and we divide both sides by 2 here. And we end up with y equals minus 3 halves times x minus 1 half. So there's my slope, and there's my y-intercept. So m equals negative 3 halves, down 3 over 2, and b is negative 1 half, which is the point 0 minus 1 half. Okay, so let me set up this again. I'm going to set it up kind of a little bit higher, perhaps, just to make sure we have lots of room on the graph. So my y-intercept is 0 minus 1 half. So I go to 0 and minus 1 half. I'm going to be right there halfway. And then my point is it goes down 3 halves. So if I'm counting here, I go down 1 half, 2 halves, 3 halves. Or I could do it this way, 3 over 2. So 1, 2, 3. So we come down 3.5, and then over 2. So our point's going to be sitting right here. By the way, I could do that again and go 1, 2, 3, and then over 2, and get another point. I could even go up 2. I could go up 1, 2, 3, and over 2, and have that point. And you'll notice all of those 4 points line up on the same line. And that's our last problem. All right, I hope this helps. Have a good day in school.